Okay, hey guys, so this will be my little introduction into trigonometry. And to start off, let's start off with an example of when you might need to learn this. Let's say in the future, you want to, or you are a carpenter, and your task is to build a ramp. So that people in wheelchairs or even people using strollers can use the ramp to go to a higher place. So let's draw a quick picture of the ramp. Maybe something like that. This ramp shouldn't be too high. So maybe like this. Something like that. Okay, and so let's say that we have, maybe over here, we have a door. So the door is over here. So over here we would obviously have the path leading to the door. And so you're starting over here. This is our bottom. The bottom of the ramp. And say this is our, oh whoops, over here, this would be the top of the ramp. And let's say that we know that the distance from the bottom of the ramp to the top of the ramp, let's say that we know that distance to be 8 meters is too much. What would be a reasonable length for that ramp? Maybe 3 meters, let's say that. 4, let's say 4 meters. So 4 meters is the distance from the bottom of the ramp to the top of the ramp. And let's say that at the height of the ramp is, let's say it's 0.5 meters. Is that too much? No, I think it's reasonable. Let's say 0.7, just for kicks. 0.7 meters. Okay, now my question would be, how much material would I need to build this segment of the ramp? So to build the ramp itself, how much material would I need? So let's say that we have an angle as well. So this angle over here, we're going to call it theta. I know you guys in the past have used the variable x for the angle, but I'm just going to not use x because sometimes x is used as a variable or as a variable for the length and the width. So I don't want to confuse you guys. So I'm going to try to keep it consistent by using theta as the angle. Let's say that we know that this angle here, what's a reasonable angle for a ramp? Maybe 12 degrees, okay? And so my question would be, what does my hypotenuse have to be? What does my hypotenuse have to be? So there are a number of tools that we can use to find out what this hypotenuse has to be. So you guys know that this is a right angle triangle. A right angle triangle is shown if there is a little square in the corner. And this square means that this angle over here, this angle over here is 90 degrees, which is also called a right angle. This is obviously all review, right? Right angle, which makes this a right angle triangle. Just to label this triangle right now, this 4 meters here, let's just start off with a few things. Okay, so we have here our angle, which is 12 degrees. Opposite to this angle would be called the opposite. OPP. The longest side of the right angle triangle, which is also opposite to the 90-degree angle, is called the hypotenuse, which is a word that you've heard me use just now, hypotenuse. And the acronym, I feel like I spelled this wrong. Tell me if I spelled it wrong. It looks odd to me right now. The acronym is HYP. And adjacent, adjacent is a word to mean next to. So the adjacent of this angle is called the adjacent. So adjacent just means next to. So ADJ, and that's a short form for the word adjacent. I said acronym before. What I meant to say was short form. Okay, so we labeled our right angle triangle. Now let's actually try to figure out what tools we need. So we have 3 tools at our disposal in trigonometry. The first tool, so I'll label it number 1, is something called sine. And the equation is sine theta equals opposite. Am I going to stick with my color coordinating? Sure. Opposite over hypotenuse. Eek. The other one is called cosine. I'm going to use green. And cosine is adjacent over hypotenuse. ADJ over HYP. Finally, for tangent, let's go with blue. Tangent theta equals opposite over adjacent. So you may be asking yourself, how am I supposed to memorize all these formulas, these 3 formulas over here, because it has all these combinations of opposite, hypotenuse, and adjacent. You don't have to memorize the formula like this in this format. You can use an acronym that is actually quite helpful. And this acronym is SO, CA, and TOA. Just remember SOCA, TOA, and you'll be fine for trigonometry. So this is basically what you are responsible for. If you know this, you'll be fine for this unit. SO stands for sine equals opposite over here over hypotenuse over here. Cos. The C in CA stands for cos. The A in CA stands for adjacent. And the H stands for hypotenuse. Why did I write my hypotenuse in orange over here when it should be purple? The T in TOA stands for tan, O stands for opposite, and A stands for adjacent. Now, let's actually use one of these formulas to solve our question right here. We want to find hypotenuse, right? Oh, I don't need any of this to find hypotenuse. Let's say that I wasn't given how high this ramp is. So I'm not given my opposite, but I only have my adjacent, and I have my angle. So in this example over here, the ramp example, let me just label that. So let's call this example 1. Example 1, and this is my ramp example. All right, in my ramp example, what am I given? What am I given? What does the question give me? The question gives me, remember I took away this value for opposite. So what does it actually give me? It gives me an angle. I can see an angle. My angle is 12 degrees. And I also have my adjacent. So ADJ equals what? 4 meters. Also, I recognize that this is meters. Therefore, my answer for the hypotenuse also has to have the same units, which would be meters. Okay, and what am I looking for? So this is my givens. What am I looking for? Find. What am I looking for? Find. I'm looking for my hypotenuse. How? So my question is, how long is the ramp? So I'm looking for the length of the ramp. Length of ramp equals hypotenuse. Looking for my hypotenuse. And now what am I going to use to find my hypotenuse? I have the adjacent. My adjacent is pink. I have my adjacent. I'm looking for the hypotenuse